Hello, 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 hello. Welcome back. Grab yourself some popcorn, fasten your seatbelt. This problem is going to take a while. Here we go. We have a conservation of momentum problem in two dimensions. We have two balls colliding. They're actually colliding from the top. So you have this 40 kilometer ball coming in this way, and this 90 coming in this way, and they're colliding from the top. And after the collision, the 40 ball gets sent off this way, and the 90 gets sent off this way. So when we number these, let's number this guy number 1. This guy's number 2. So those are the two before the collision, and then after the collision, we have number 1, and we have number 2. So this problem is going to be similar to the vector addition we did for the forces from the last unit. We're going to have to break all of these up into x and y components, and we're basically going to have to use the collision one-dimension equation, that long equation, for both parts, the x part and the y part. So to start, we're going to make ourselves a lovely little chart. We're going to have a row here for the x column and the y column. And we're going to break this up for velocity 1, that is this guy, before the collision. We have velocity 2, that's this guy, before the collision. And I'm going to run out of room. We have velocity 1 after the collision. That's this guy down here. And we have v2 after the collision. All right, we are going to use our trig functions. So for the x part, for number 1, is basically going to be 60 cosine 40. Oops, sorry, cosine 30. And the y part would be 60 sine 30. For the second velocity vector, once again, that's this guy right here. We have 80 cosine 45. And for the y part is our sine. For v1 prime, the next one, remember that's this guy over here. We have 70 cosine 20. And 70 sine 20. And for the y part, for v2 prime, it's this guy, and that's just our question mark. We don't know what that is. All right, simplify this. I'm just going to put it in the calculator. In fact, I already did that. I'm just going to tell you the answers. This is 51.96. We have negative 30. It's negative because it is going down 30. For our second velocity, it is going left. The x part is going left, so it is also negative 56.57, and it is also going down, so it is a negative 56.57 also. For v1 prime, it is going left, so it is a negative 65.78. And the y is negative because it's going down 23.94. All right, so what I found were the velocity components for each of these. Now I'm going to plug it into my equation. I'm going to do it once for the x part. So for the x part, I have m1v1 plus m2v2 equals m1v1 prime plus m2v2 prime. So I'm just going to plug in my numbers. Mass for number 1 is 40. I got that number from right here. Velocity 1, that is going to be this number right here, 51.96. Mass 2, that's that guy, that's my 90. Velocity 2, that's here. I'm sticking with the x part at negative 56.57. M1 is still 40. That would be this mass. And how fast is it going? Right there, negative 65.78 plus M2, which is my 90. It's my second velocity. And we don't know how fast it's going. I'm just going to call it Vx prime because this is in the x direction. And so now it just comes into a plug and chug. Actually, we already plugged, we just got to chug. And we're basically going to get 2078.4 minus 5091.3 equals negative 2631.2 plus 90 Vx prime. I'm going to subtract, and I'm also going to add that 2631.2 from the right side, and I'm going to get negative 381.7 equals 90 Vx prime. So I get my Vx prime equal to negative 4.24. Great. That is my answer for the velocity in the x direction. I need to do the same thing for the y direction. So for the y part, I'm going to have m1v1 plus m2v2 equals m1v1 prime plus m2v2 prime. So I'm doing this for the y's. So I have the mass, which is still 40. And now I need the y part of v1. That is going to be this guy right here, negative 30. Plus m2, that's my second mass, that's my 90. v2 is that guy, negative 56.57, equals, mass 1 is 40, v1 is right there, negative 23.94, my second mass is 90, and I don't know how fast it's going. All right. Pull up the calculator, crunch it out. I get negative 1200 minus 5091.3 equals negative 957.6 plus 90 V2 prime. I'm going to subtract and then add, combine all those numbers. I get negative 5333.7 equals 90 V2 prime. And I'm going to call this my Vy, because this is my y direction. After, I get a negative 52.26. So now I have the answer in the x direction, I have the answer in the y direction, and just like we did for those other problems, I'm going to use the Pythagorean theorem. So a squared plus b squared equals c squared. To find the final answer, I'm going to plug in my y, negative my x, negative 4.24 squared plus negative 52.26 squared. And I get 59.41 meters per second. That is my answer. And to get the theta, the angle, I'm going to do it the same way as I did last unit. I'm going to use the inverse tangent of my y over my x, negative 52.26 over negative 4.24, and that will give me an angle of 85.9 degrees. So those are my two answers.